Okay, now nice to see you all, or at least your pictures of you. Yes, Jahangir has added in the chat box that in this day, 6th of November, we are celebrating Swedish language in Finland, because we have this is bilingual. Yes, bilingual country. The two official languages, Finnish and Swedish, and in Finland there lives about maybe 5% about of Finns are Swedish speaking. We have long common history with Sweden, and actually in that intra page in Seamk you can find a video where I am interviewed in Swedish language. I try to speak some Swedish there. I may put link there when I find it, or if someone finds that link. So today we are taking one item which we have not handled yet. I will give a title, which is some special equations. Last time we had we had a determinant which we handled, and there we got some applications where we used determinants when solving pair of equations or systems of equation, or at least we got an example how to solve three equations with three unknowns with the help of determinants. In the Moodle page you may found their PDF file, which I guess I named determinants, and there I used another way to calculate the value of 3 times 3 determinant. It is a little bit different the way to calculate the value, but both are good to know. We used last week so-called SARU rule, and in that the other example which you can find from that PDF file, I used a maybe more common way to calculate the value of determinant. Some special equations. There are some equation types which need to be solved a little bit different way as usual. And first I will take root equations. And this means equations where there are roots, for example square roots or cubic roots. And these are equations where we need to get another way to solve because the earlier methods doesn't work there. So let's take first example. Oh, sorry. Yeah, thank you for saying. I hate this Teams because I wonder why can't this show for a presenter what what others can see and what not. So now I have to share this. Thank you. I hope now you can see. I wrote some special equations there and root equations, and now I'm starting the example. And sorry again, I'm watching the wrong camera all the time. I forget which camera is filming me. Example 1. Let's take this kind of example. X, nothing special yet, but then I take square root of x equals 2. So now we actually have the step in the equation where all the x's are in the left hand side, but it doesn't help us because there are x and there are square root of x, and we can sum between them, or plus sign between them, but we can't sum them because the other one is inside the square root. So we can't solve this immediately from this step. But the usual method when we are having an equation where there are roots, I think most common method is to leave the root part on the left hand side or on the right hand side of the equation lonely, so there is only that root sign there. So for example here this square root of x is in the left hand side, so I will move this x to the right hand side, so that leaves the square root only in the left hand side. So we have square root of x equals 2 minus x, sign change there. And now we have the step where we have root only in the left hand side, or it doesn't matter if it is in the right hand side. We will continue with the same method. And now when we are having a square root there, so we will use power. So to get rid of that square root, we have to raise that to the power of 2. So we will do that. Both sides of the equation are raised to the power of 2. This notation here means that inside the brackets I will put both sides of the equations, and both sides will be raised to the power of 2. So that means in this step we get this equation more difficult as earlier, because now we not only have the square root there, but now we also have the power there, or exponent there. But things will be better soon, because now we will see here that we have here square root and exponent 2. They will eliminate each other. So in the left hand side we get only just a simple x, because square root x raised to the power of 2 equals x. This is the same thing as happens, for example, in any number. If I get brackets, also you can't see this. I'll take another calculator, maybe you see this better. So I'll get brackets there and square root, for example 9, and now I will raise this to the power of 2, and as you understand or know, it leaves only the 9 there, so it is the number inside of square root. So in this case we have this x in the left hand side, and it is raised to the power square root of x, and it is raised to the power of 2, so that leaves only simple x there. And in the right hand side there is subtraction between two numbers or two figures there, and we may use the memory rule there. This in root equations many times, mostly when we have square root in equation, we have one step in our solution where we need to do something like this. So in this case we will use this memory rule in algebra. A minus b squared equals a squared minus 2ab plus b squared. This is a formula which is useful in root equations. So in this case we have here 2 squared minus 2 times a times b, 2 times x plus b squared, and in this case x squared. I will write in, this is a squared, this is 2 times a times b, and this is b squared. Most common error when solving root equations comes in these steps. So in this step you have to be very careful to use correctly that formula there. So what do we have? X equals 4 minus 4x plus x squared. And now we see that we have an equation where there are exponent 2, so that means this is a second order or quadratic equation. So we have to solve this so that we will move everything in the same side of the equation, for example to the left hand side. So let's do that. I will move everything to the left hand side. Of course I could do also so that I would move this x to the right hand side, but now I will do it in this method. So we will get x minus 4 plus 4x minus x squared, and then there is only 0 in the right hand side. I will write this in the order of descending exponents or descending powers. Minus x squared, then we have 4x and x, it's totally plus 5x minus 4. And now we have the second order equation or quadratic equation, and we will use the solution formula for this. I will show it from my book here. This we used in the earlier in this, during this autumn, this equation, and this is the solution. So now a is the factor in front of x squared, so it is now, there is only minus, so that means it is a must be minus 1. B equals 5 and c equals minus 4. And the solution of this will be, I write the formula in the right hand side of this page. X equals minus b plus minus square root b squared minus 4ac 2 times a in the bottom of this fraction. So now we have minus 5 plus minus 5 squared minus 4 times minus 1 times minus 4. Just add the numbers in the place of these figures there, and then here in the bottom part 2 times minus 1. So mostly these square formula equations which have square roots, mostly they in one step in the solution you need to use this formula for the second order equation. And what we'll have, note that we will have two solutions here, plus minus. That means that this equation probably may have two solutions. Yes, did you have something to ask? Or so there may be two solutions of this equation, but let's see what happens. In this case, the solution is quite simple. There are only whole numbers in the solution. Two possible solutions. This in root equations we have to be very careful, because we may not be 100% sure that these both are solutions for this equation. Let's see what happens now. I will use indexes or indices there. x1 I will take the plus sign there, -5 plus 3 divided by -2. So this means it will be -2 minus 2 it equals 1. So this is one solution, one possible solution of the equation. And the other one is the one which we use the minus sign in this solution. -5 minus 3 divided by -2. -8 divided by -2 equals 4. But as I told, we may not be quite sure if these are solutions for this equation, because actually these are. We may be quite sure if I have solved this second degree equation correctly from this states to this states. I probably may be quite sure that everything I have made correctly. But the problem is that these numbers, or these x values here, 1 and 4, those are solutions for this equation, or also this equation, and also these equations. But if we go more to the initial states, towards the initial states of this equation, we actually do one thing, or one method which we use here. This may cause that we will get solutions for equations, for these equations that actually are not anymore solutions for this first equation here. Probably other one is the solution, but not necessarily. It may be so that both are incorrect solutions. But let's check. Note, check always solutions of the root equation. Yes.
Should we write two of them or just one in the answer sheet?
Sorry, can you repeat?
Should we just write down the two of these answer x1, x2, or just we have to find out the most relevant answer for the solution?
We need to calculate both them, but we always have to check if they are correct solutions for this initial equation. We can't be sure. So we need to calculate both these, but after that we need to check the solutions.
Yes, I got it. Thank you.
Yeah. So now when x equals 1, this first solution here, and we will take the initial equation. It was this. So we will take the first one here, not this one or this one or this one, but the first here. I will write the equation here again. So the left hand side or if we use LHS, x plus square root x equals, and if we substitute this 1 in the place of x here, we will get 1 plus square root of 1. Well, square root of 1 is same as 1, so we have 1 plus 1 equals 2. And in the initial equation, the right hand side, there is nothing to calculate there because it tells there is only 2. So now we see that this solution x equals 1 gives the same value to the left hand side and to the right hand side. So this means that x is a solution for x equals 1 is a solution. This was such a simple equation that you could guess the solution when you watch this equation there. 1 plus 1 and the square root of 1, of course that is 2. But there may be another solution also, and now we have one candidate there. It may be x equals 4. So let's take that. And now the same initial equation there. We get left hand side, we have x plus square root of x. So we have 4 plus square root of 4. This is same as 4 plus 2 equals 6. And this right hand side was 2. And now we see that these are not same. And that means that this x value of 4 in the place of x is not a solution for this initial equation. So the final answer for the solution, it is only x equals 1. So there is only one solution for this equation. This was very simple equation in that meaning that the solutions were very simple ones. There were whole numbers there, and it was a reason for me to take this kind of equation in the beginning, because this is easy to quite easy to solve and very easy to check. But mostly the solutions are some decimal numbers there, and when we are using decimal numbers here, we mostly have to use a rounded value, and when we are checking the solution, if that is correct or incorrect, we need to use lots of decimals there, because if we round those values too much, we can't be sure if that is solution. For example, if we had in the place of 1 some decimal numbers, for example 1.235, so whatever, and if we place it here, we may get, for example, 2.1 there, and the right hand side, sorry, here 2.1, and the right hand side would be 2, so that would make me or us to guess that maybe that was not a solution for the equation, but the difference between the values may be because of the too rounded value of the solution. So in the checking you use many decimals there. Okay. I will take another example. Here I found paper. Example 2. I said earlier that mostly we get quadratic equation when we are solving root equations, but not necessarily. For example, we may have this kind of equation. In this case, it is possible to use the raising method, or raise this to the power of 2 in this from in the beginning already, but I suggest that it would be helpful if we divide this 4 away from this left hand side. It is not necessary in this example, but I think it is many times easier when you have only a square root there, nothing in front of it. So I will do the dividing, so I will divide this 4 away. Well, this is easy to calculate in your head without using calculator. So when you are calculating only in your head, you will get the result 0.9. I want it to be exact, that I will get the correct solution there. And after this we may use again the exponent method, or raising to the power of 2. So now we have the square root in the left hand side, and it will be raised to the power of 2, and the same happens in the right hand side. This step is quite critical here. I think when I have checked students' solutions in this kind of problems many times, and I think myself also, if I make an error in this solution, I many times may forget to raise the right hand side to the power of 2, so you have to be careful. Many times you may have in the paper the exponent or power there, but when we check the next step, we see that we have forgotten to do that raising. So in the left hand side we can eliminate the root sign there, so we only get x minus 2.5, and here, well, this is easy, 0.81. Let's check. 0.81. So that leaves us very simple equation. Now we only have to move this 2.5 to the right hand side, and that leaves us 0.81 plus 2.5. I will check that. 3.31. And again, when we are, every time we are using this raising method there we have to check the solution. And again, the initial equation, not any other step, only the first equation there. Left hand side. So I will. Now, of course, I could solve the. So we get 4 and square root of 0.81, and well, this is quite easy to see that this will get us the same value as in the right hand side. And that means that the answer we got was the solution of the initial equation. And this was the only solution in this case. I will have a break, but I will give you some problems to solve during the break if you like to. I hope others see my notes here. Yeah, I don't know what is the problem there. I will give you two problems there. Yes. You put the page. I will zoom this a little bit. How do I? I have a small documentary camera here, and sometimes it is very hard to use. I think now you can see everything. So let's have 15 minutes break here and let's continue in Finland time zone. It is now 2 minutes past 13, so we will continue about 13:15. I would have to stop the recording.